So let's pick up where we left off. So we're creating a deleted up. Sorry, I'm imitating my son who's just learned the word up, and it is like the funnest thing ever. So new entry, right? And this deleted node doesn't have to hold anything, so it's just going to hold nulls for the key and value. But this will essentially be a, you know, a null that holds key value. Just cache. Oh, right. Private static, right? So we don't. So it's not going to have key values in it. It's just going to be that because it's static. Okay. So it's a delete. So this here, rather than so what we're going to do is rather than setting. So this requires a couple changes on our part. Right, rather than deleting something, what we're going to do is we're going to, to delete something, rather than setting it to null, we'll set it to deleted. Because, right, our computer is interpreting null as it was never there in the first place. Now we can't, so the find method, I don't really want to change that too much, right? I really don't want to change the find method. In fact, I'm pretty lazy. I don't really want to change much at all. So the idea here is that everything's going to work under the same assumption. Null, if it hits a null, that means it's an empty space I can take up. So I'm not going to decrement the size if I delete something. Right, I'm just not going to decrement the size if I delete something. It's essentially going to be wasted space until we rehash. Okay, so I just simply replace it with deleted. Okay, so that really won't change much about the way it works at all. And now when we rehash, that's when we'll use the opportunity to get rid of these deleted nodes. Oh, sorry. Actually, I will have to keep decrementing the size because technically, since we deleted it, right, to the user, it's still got to look like, you know, we're taking care of business. The user has got to look like we've taken care of business. But now our size isn't indicative of how filled up the hash table is. So keep a track of num deleted. Right, and that will be this dot num deleted equal to 0. And now we'll do size plus num deleted times 1. That's the amount of space that's currently used up. And while that space has been used up, when that amount of space has been used up, we are going to go ahead and rehash. Just checking on him. He got a snack. Could take that out with the magic of video editing if I wasn't so lazy. Alright, so we've deleted that, so we've reduced the size, but we increased the number of deleted. Okay, and now all I really have to do to fix our hash table is now jettison those deleted nodes. I mean, I don't technically have to. It's just probably a good idea to jettison those deleted nulls when we are rehashing. So if old table is equal to null, if the ith index of old table is equal to null, or old table I is equal to deleted, then we'll skip it. Otherwise, grab the key value and insert it. And that should work now. And so now if I do delete, whoops, what fresh thing did I get myself into? Table, so at find 78, so find key. So while index is not equal to null, and index.key.equals key. So I tried to grab the key over there, right? I tried to use the dot equals method on that. So I have to do it the other way around now, right? Because I tried to, so if it's a deleted node, I'm doing the, null dot equals. That seems like a poor choice, but I think I can get around that without having to do too much. So we can do key dot equals instead. the table.key, and now let's see if that helps us. There we go. And so now the example where we had, so now when we deleted that node, when we delete down here, when we delete 16 over here, we had the values null and null. And now we have, so we just simply set it to null. And now we have the entries null and null, sorry, the entry null null to replace it. So now our contains method, what does it do? It goes and looks, okay, looking for 15. 15 gets hashed to this space over here. So 15 mod 11 goes over here to index 4. We check the next, there's a collision there, so we check over to the next space. Collision there, we check over the next space. Found key 15, right? It just treats this one like any other. And treating it like that, well, it's a bit obtuse, and yeah, we're technically wasting some space until we rehash again. I mean, we're already wasting plenty of space, so I'm not really concerned about that at that point. We could write it so that, we could write it so that basically our put method doesn't rely on find, and instead, if it finds a deleted, it takes that one instead. But if it did, right? If it did, right? You might end up in the same problem, right? Really, there's no way to get around. So actually, this is a terrible idea. So really, there's no way to get around not using these deleted nulls, sorry, these deleted nodes. And think about why basically rewriting the put method to take account for these entries wouldn't work, right? You're going to end up in the similar situation as that. So, but that's really it. Now, let's go ahead and fix our toString method so that it gets prettier. So first off, instead of doing this, we'll just do plus. We'll do plus happy feet plus comma space plus value plus. So now when we run hash table, it's gonna now look a bit nicer for us. So we now see a few more ordered pairs like that. And now probably don't want to show those nulls to the user. So probably it's going to be something more along the lines of this. So string buffer, so string builder out is equal to new string builder for entry in table out.append, sorry, if entry equals null, sorry, so if it's, yeah, so if it's an equal to null or its entry is equal to deleted, we'll just skip it. Otherwise, entry.append or add, no, not entry.append, out.append the entry. Then return out.toString. Oh, and we'll want to do that plus comma space. Oh, right. Well, now we have our fence posting problem. So I'm just going to go ahead and do commas and be done with it. So no commas and be done with it. Ta-da! All right, so we now have a very rudimentary hash table using open addressing up and running. So that's it for real. And yeah, building them was slightly confusing, but they're really not too bad. So go ahead and look this over. We're going to continue on. So this is what you need for Monday. On Wednesday, we are going to. He's just climbing all over the place. He's climbing all over the place. Nah, it's fine. But on Wednesday, we are going to you're expected to watch some videos on that will go over. It's going to go over essentially the other ways we can do open addressing, right? Because we're just going forward and looking at the next one. And we'll also cover a bit about chaining and then how can we expect. I keep claiming this is constant time, but I haven't shown it yet, so we'll have to go over that. But that will be it for you guys to go over. Okay, so I'm going to go ahead and start uploading these things.